Hi. Okay, so as you may know, I was not actually scheduled to speak here, or at least to give this talk. And that is because my friend Ujwal couldn't make it to the conference and give his talk about ES modules. But I just as a really quick update, the current status of ES modules in Node.js is basically there is a PR open to unflag experimental modules, and it should land pretty soon, assuming we get these crashes in CI figured out. But yeah, it's not going to take long until we have that resolved, I think. Okay, now, back to this. So I'm Anna. I work for NearForm. You may recognize this NearForm research logo thingy from James's talk. So yeah, I've been working on Node.js for a while now, nearly 4 years. And I work full-time on Node.js. You may know me from things like Workers, or from the talk I gave you last year about that topic. And I've also been involved in making things like HTTP2 and Broadly and other things for Node.js happening. Again, as James mentioned, we're working on HTTP3 and Quick right now. And yeah, I like talking about Node internals and giving people a bit more overview over how Node.js works. And and actually, in a way, this is a really good slot for this talk. Only 2 after Shelley's talk, because it's easy to build on that actually. Okay, so first of all, set timeout. Where does that actually come from? And a lot of you might actually be thinking, hey, set timeout is part of JavaScript, right? But if you look into this JavaScript spec and you look for set timeout, you get stuff about modules, stuff about regex matches, but there's no mention of that. And if you think a bit more about it, it kind of makes sense. Let's take a look at this code example. We create a socket, we try to connect to a server, and we set a timeout with 1,000 seconds. Now think about what the application actually does in this scenario. And I want to try to show this. So I have this code stored in a file, connect to a server, create a timeout, and so on Linux, which is what I'm using, epoll wait is what Node.js uses to talk to the operating system about what it should do on the event loop. And so you may see that epoll wait, so the event loop waiting function, is actually called with arguments that look kind of like 1,000 milliseconds. And the reason for that is that timeouts and other things on the event loop have to be integrated into each other. The idea is that the event loop tells the operating system, hey, wait for any of these events to happen, or the timeout whenever that happens, whatever happens first. So yeah, it's managed by the event loop, in our case, Libuv, the event loop library for Node.js. So if we want to implement set timeout from scratch, what we have to look at is there are some central concepts in Libuv, basically 2 different kinds of classes for objects. One is handles. So these are things like network sockets that occasionally repeat emitting events, basically, like event emitters. For example, network sockets that emit data from time to time. And then there's requests, which do one thing once, kind of like an async function call. For example, reading from a file. You get one result, and that's it. And so timers, which you pass one function to, that's called once, are of course implemented as handles, which may seem counterintuitive. The reason for that is kind of simple. There's also set interval in Node.js, and Libuv provides the same kind of timer for both of these. And set interval is something that calls us callback multiple times. So if we want to re-implement set timeout again, there's some data we need to start. So the actual timeout function that we want to call that was passed to set timeout some Libuv data, including, so which event loop is this about? How long should we wait? All that kind of stuff. The actual timeout function is a JavaScript function, so we need a JavaScript object to store that somewhere. The Libuv timer class is a C class, so we need a C++ object to attach it to that JavaScript object. And one thing that it's not technically necessary, but Node.js is kind of built in a way to make this the easiest approach, is async tracking. So we store data that allows people to track where the async call for a set timeout, where it came from, and when this set timeout actually happens, to associate these two events with each other. We have some internal helper classes that I'm going to show you in fake JavaScript. So these are C++ classes, and I'm going to go over them real quick. So at the top of our class hierarchy, a lot of our classes inherit from this memory retainer thing, which is basically saying this is a thing that should show up in a heap dump. So something that we track memory for. We have one step below, something called base object, which means, so there's a JavaScript object, there's a C++ object, and they're tied to each other in some way. Typically, that means like, for example, something like when the JavaScript object is garbage collected, that the C++ object gets deleted or something like that. There are options for that. And this environment thing, env, I'm not going to go into a lot of detail about that, but it's basically a Node.js instance, if you want to think about it that way. So for example, if you have multiple workers in an application, every one of these workers has its own environment. Again, one step below, we have something called async wrap. And the idea is this is something that we use for async tracking that basically comes built in with that. And every async wrap instance, it gets a set of IDs that allow people who do async tracing to associate the resource that is created at some point, for example, a timer, with the callback or the event that it's emitting. And I'm not going into a lot of detail about this. Just going to mention this make callback thing. It's like when I first got started with Node.js with native development. In the beginning, that was native add-ons. There's this make callback function in Node's public API that you're supposed to use, but it took me a really long time to get what this did, because it doesn't make a callback. It makes a callback into JavaScript, and yeah, for me that really wasn't obvious. But the idea is, so if you're calling from the event loop itself, from something that does not have a JavaScript stack below it, we run the callback that was supposed to be run originally, plus we run things like next take, the promises, microtask queue, and we tell async tracking, hey, these are the things that are currently happening. And then again, one step below, there's this handle wrap thingy, which is an async wrap, which is a base object, which is a memory tracker, and it has some helpers for dealing with Libuv handles. In this concrete case, so there's a close function which kind of does what you might think it does. It closes the Libuv handle, it renders it unusable, basically, kind of like deleting it. We have ref and unref. Unref, a lot of you might know what it is, but in case you don't, this is basically telling Libuv, hey, do not keep the event loop alive if this is the only thing that's still active at the end of the process. And ref undoes that. And so if we want to associate a Libuv timer with a JavaScript function, this is how Node.js writes its boilerplate wrapper code. We create a timer using this, like telling it, hey, Libuv, please create a timer, initialize it. This is the event loop that it's for. We provide a start function that tells Libuv, hey, we want a timer that runs after this many milliseconds, and it doesn't repeat. That's what the 0 is for. And we pass it a callback, which cannot be directly the JavaScript callback because Libuv is a C library, and it has no idea what a JavaScript callback is. So we pass it our own, and we do this make callback thingy from there, so callback into JavaScript. And like this is actually a bit similar to one of Shelley's slides, but just so you know, so when you call set timeout, that actually calls a function defined in a public module that's in the Node.js source tree at libtimers.js that calls internal binding, which is, you know, as she said, it's not really what you're supposed to use, except if you're doing Node core development, which we are doing, so it's fine. And that calls into a C++ file that talks to Libuv, and what that does, we don't care about. It talks to the operating system in some way. Okay. So let's actually get started with live coding. I'm going to go back to this slide because this is what we want to write, except for it being C++ and not JavaScript. I hope the font size is large enough for everybody to read it. I think something like this should work. And so the first thing we're going to do is we're going to start by cheating. Because C++ doesn't really have a module system. Okay, sorry. And its module system is more like, hey, please copy paste these files into my own file when you're compiling it, which is really, really not pretty. So there are some includes that I've added, some kind of imports if you want to look at it that way, and some V8 functionality that we want to use. And I just know that because I've practiced this talk, and you know, I know what we have to use. Okay. Okay, so let's actually get started with this timer thingy. Also, if you see me doing something weird when I'm writing a C, there's a reason for that. And that is that my C key on my laptop is broken, actually. But you know, it has been for a while, and so I'm pretty used to it. This is kind of like this .timer is the new timer. If this were JavaScript, what arguments should it take? It should take the environment and the JavaScript object. And yeah, I think Shelley mentioned a bit, but this is basically how you access JavaScript values from C++. And this part with the colon thingy, colon handle wrap, this is kind of like a super call, except in C++. So we need to tell it hey, so here's the handle that we're using, and we need to tell it, okay, this is a timer. And so we actually have a list of all the different types of async things that can exist in Node.js. And yeah, so these are the ones that are built in. As a user, you can define more if you're doing your own async tracking thing for a library. For example, worker pool libraries do that. But yeah, anyway, so we add a timer as a new type. The reason that it's not already there for our existing timers is that they are implemented very differently from what I'm doing here, but I'm going to go into more detail on that later. And inside, I think I said I want to do something like, yeah, initialize the timer. And I think the arguments it takes us, okay, it's the event loop, which we get from the Node.js instance, again, whatever that means, but it is associated with an event loop. And we say, hey, this is the timer we want to initialize. I also said we want this like start function. So one thing that's a bit unfortunate is that unlike Electron, we're not using this fancy gin library. I guess it's a bit easier for them because they, well, they're already importing Chromium, right? And they're already having their full source tree available. Node.js doesn't do that. We only take V8 and not anything from Chromium directly. Okay, so I wanted to call UV timer start from here, but so we need to access the timer object in some way from this arguments list. And there's kind of just a boilerplate approach to that. And I think this is what it's called, but I always get it wrong, and I have to look it up each time I do this talk. I know there are the words assign, return, unwrap, and or in there. Basically says, please, so this is where I want to have my native C++ object, and please get it from this value that was passed to this function call. And another thing, again, that we don't do, we have no fancy way of extracting values from JavaScript objects, so we have to do it very manually. And I'm going to skip over validation here because, so the thing is, in Node.js, we usually do type validation at the JavaScript level. Kind of because it's easier and, well, if you do it the right way, it might also be more performant or not. But yeah, anyway, so the first argument is supposed to be a number. And again, this is just, okay, so the first argument, we take the number value of it, we pass to it a context thing. The reason for that is that, so converting something to number can fail, and that would create an exception, and we need to know what global object that exception would be for, and that's kind of what the context does here. But from just basically says, if there's an exception, just crash the process. We've done our type checking, we promise. Yeah. Okay, so calling UV timer start. We pass to the timer, and the callback that I still have to define, the C++ callback. We say there's a timer in milliseconds that we pass to it, and don't repeat this. Okay, so what does that callback look like? This is the format that Libuv expects the callback to be in. And again, there's some kind of boilerplate code for dealing with the situation where you get a callback from Libuv, and you have access to a field in that class that we really want to get to. And this is something you wouldn't be able to do in JavaScript. What we can do is we can use this container of thing, which basically takes a field in a class and gives you the original object. Yeah, that's just because of the way that C++ works that we can do something like this. Otherwise, we would have to store the timer wrap in a way in the Libuv timer, which is also possible, but yeah, it's not really what we do. And this is how Node.js code looks like most of the time. So in this Libuv callback, we want to call into JavaScript. So what we need to do is we need to tell V8, hey, we are ready to call into JavaScript. We create a handle scope, which basically means, hey, V8 garbage collector, we're about to access JavaScript objects, and please keep track of the ones that we access for us, so we don't lose. Well, so for example, that we get informed if they are moved around during garbage collection or something like that, so we don't access the wrong memory address. We also have to tell V8, hey, this is the global object that we want to use for our callback. Right. So once we are here, what we do is we call this make callback function from this async rec thingy. We tell it, okay, so the method that we want to call is called onTimeout. And we don't want to pass any arguments to it. So 0 arguments, the list is null. I think I'm doing this right. I'm always checking with other parts of the code base to see if what I'm doing is right, because that works, and this code hopefully does too. And this onTimeout string, so what we have is inside Node.js, we have a list of strings that we reuse. So a list of strings that that might be used multiple times during the execution of a Node.js program, so that we not have to create a new string every time that we use that. Yeah, on timeout. I think I spelled that right. Okay, one more thing we need to be, so we have a constructor defined here, but V8 really doesn't know what to do with that kind of thing. So what we need to do is create a constructor function that kind of looks like the start function here, because that is the format that V8 can understand. And so we have a way to figure out the current Node.js instance from that arguments list. I'm not going to go into detail about what that is, but there is a way, and this is something you will find very commonly as the first line in Node.js C++ bindings. And we create this new timer wrap object. And because this is a constructor we associated with this object inside the constructor. And if you're like a seasoned C++ programmer or something, you'll notice, hey, so this is creating a new object, allocating it, and we don't store the pointer anywhere, which is usually a pretty bad sign because that means that there's a memory leak because we don't use the object. In this case, it's fine because what that timer wrap thing does, it calls the handle wrap constructor, which calls the async wrap constructor, calls the base object constructor. And that associates the JavaScript object and the C++ objects with each other. And so we actually have something that controls the lifetime of this object. Okay. This should nearly be working. And so I'm going to kind of cheat again. Because, again, we don't use gin or something like that. We have to create this JavaScript class manually that we want to use. And luckily, there's a very similar one for stat watchers, which are file system watchers that regularly run stat on a file to see if it's changed. And it just happens to work the same way that timers do. Like, we have a constructor. We set the class name to timer wrap, and it's a handle wrap, so it inherits from that. And it also has a start function, like that stat washer thing. Okay, let's compile Node.js. So while that's happening, and it's probably not going to fully work the way I want it to, because writing C++ and compiling it on the first thread doesn't always work out. But one thing that I did for fun, I benchmarked one of these implementations that I wrote for this talk, which is called cool in this example, against the boring standard implementation that Node.js comes with. And you'll see it's more than 10 times slower in some cases. And the reason for that is the set timeout implementation that we have in Node.js, that wasn't written in 20 minutes. That was highly optimized. For example, so one thing that we try to avoid as much as possible for performance in Node.js is C++ and JavaScript boundary crossings. So calling from one language into the other, that comes with some costs. So what our timers implementation does, it groups timers that have the same duration. So so they are run directly after each other in JavaScript, for example. And there's always one Libuv timer handle only active at a time. The rest of, the list of set timeouts is actually maintained in JavaScript itself. Things like that. Okay, so that failed. Usually, those are only typos, something that I can fix up pretty quickly. And it also happens to be that I usually make the same mistakes when I give the talk. And you would think that I'm getting used to that, but not actually, no. And So again, from the stat washer code, I forgot that, like, because this is something that we can track memory for, we have to provide some kind of memory info for that. And I'm basically saying, okay, this thing, it has a certain size, and we can compute that in C++. And, but it doesn't actually refer to any other kind of objects that we track memory for. So there's no further memory function associated with it. Okay. Because I'm kind of running out of time, I'm going to skip ahead a bit and also already write the JavaScript implementation. I'm just going to hope that this works. So from this internal binding thing for timers, which are required for internal modules, I'm importing timer wrap, which is the class that we just defined. And I'm writing new, better setTimeout function. So the signature that setTimeout takes is, it takes a function and then the delay in milliseconds and then arguments, right? We already add that to the exports list. We create this new object. Didn't take any arguments to that function, only this one, but that's always there when you create a new object. I say when the timer runs out, like from C++, we call this onTimeout function. So I'm going to call the function that was passed to that timeout function. I'm also going to close the handle, because otherwise this would be a memory leak. And, oh yeah, right, start the timer. And as you can see, I'm skipping the arguments validation step. So if you pass something that is not a number, for example, for the delay, this implementation would just crash. But it should be fine for, for just showing how this works. Okay, compiling is almost done. Sadly, it always takes a bit to compile Node.js, and it's kind of annoying, but you get used to it. And also, unfortunately, there's no way to make changes to the JavaScript parts of Node.js without having to recompile the binary itself. But anyway, so let's require timers. Okay, there's this cool setTimeout function that we just defined. I'm going to use a callback that just says hi and 1 second, and it works. Okay, yeah, so that's it for me. I hope you had some insight into how Node's internals work. I'm going to share the code on Twitter, and yeah, that's it.
All right, thank you so much, Anna. That was a very fascinating look into how Node features are made from the ground up.
Yeah.
What would you say is the biggest hurdle to getting to that point where, like, getting to the point where you can write V8 code that runs in, so writing the C++ or writing features in C++ that run up to Node? What's the biggest hurdle in that learning process?
So honestly, one big problem is that a lot of Node's internals are not very well documented. Mm-hmm. It's on my short-term to-do list to improve some of that at least. Mm-hmm. The same goes for V8. Like, they have documentation on it, but there's no real tutorial that would always be up to date for how to writing code that uses V8 or Libuv. I mean, there's documentation, there's reference documentation, but that doesn't really, like, it's not always the best for getting started, right? Mm-hmm. So yeah, that is definitely one thing.
So a pull request is some documentation to help new users kind of get into that, or just even separate documentation to help users get into that kind of thing? Or would it be impossible to maintain?
No, it's not impossible, and there's people who have written separate documentation. It's, for example, for Node internals, it's hard to keep that up to date. Uh-huh. So I do want to, like, make a pull request that explains some of these internals that I mentioned. For example, base object, like, it's once you do more advanced things with it, it's hard to know what exactly are you doing. Like, how how does lifetime management for these objects actually work? How do they, like what happens when the Node.js process shuts down with these objects? That kind of stuff.
Okay. Well, thank you so much.
Sure.